How's it going? I recently had a company reach out to me to see if I wanted to try out a fancy schmancy laser welder, and I don't know if I have the ability to say no to that question, so we got one. Good Lord, I had no idea it was gonna be this big. How the heck are we gonna do this? So this machine was sent to me by Skyfire. It is their SF Mobile WeldStar laser welding machine. It is a 2,000 watt water-cooled fiber laser welding system. I didn't really expect it to be this large. I might need to get another shipping container. Guess we just go for it. Whoa! Okay. Alright, it's much less unwieldy now that it's out of that ridiculous pallet. And honestly, it's on a very nice base, so it's not so bad to move around. But I think I got a couple hours of unpacking and setting up to do, so... Wow, take a look at all that stuff it came with. I mean, it also came with this stuff. I think I got it all set up correctly. Here's the little gun thing. It's very sci-fi. Pew, pew, pew. You got a little cabinet up at the front. And then you can see the secret of the machine. It's about 15% laser and 85% chiller. This is the wire feed mechanism, and man, we need to normalize putting badass wire feeds on everything. This is awesome. It seems they sent me a ton of extra lenses and a ton of extra nozzles. I wonder if that's because I told them what I wanted to do with this. Got the machine all set up. I'm not gonna go over all that. That's not really what this channel's about. It was all pretty self-explanatory. I watched a video from Travis Mitchell on the setup of this exact laser. He actually convinced Skyfire to send me this laser and took a phone call with me to answer all my dumb questions. So shout out, man, thank you. Anyway, I think it's mostly set up. I've messed around with the welding a little bit, and man, it is cool / and or weird. Come check this out. Not the most consistent weld in the world, but we're getting good penetration, and this is about half as high as the machine will go. So, pretty cool. I have a ton of footage messing around with this thing, and it is freaking cool. It welds, it cuts, it cleans. Now that the paint's gone, we can see that this is the property of U-Haul. Better put that paint back before I get arrested for theft. But we're 3 minutes into this video and haven't even started building a 3D printer, so we gotta move this thing along. So that video will be on Patreon. Alright, we get it. The machine's freaking cool. Now it's about time that we move on to the whole point of this video and one of the hallmarks of this channel. We're gonna put this guy on a 3D printer. So, we're gonna need a 3D printer. How about 2 of them? I got this off of Facebook Marketplace. Apparently it's from a defunct company where they would scan your foot and then 3D print the insoles right there. Hence the 2 heads, you know, because most people have 2 feet, right? But we only need 1 of these. So, let's get this cut in half. I mean, unless I want to start printing metal insoles. There we go! Man, seeing just how freaking cool these printers are and how close they are to being alive, I might have to go back and buy the rest of that guy's printer. He had a bunch of them. I bet it would be fairly trivial to revive these. And how cool would it be to just have a cabinet full of printers like this? Ay, ay, ay. I almost feel bad cutting this thing in half. That's not gonna stop me from doing it. Alright, looky there. The operation was successful, although this one suffered damages. Moment of silence. We got our 3D printer basically built. Now it's a little bit on the wibbly wobbly side, but I think first things first, I want to start taking the gantry apart and figuring out how we're gonna mount our torch, because that's gonna, you know, denote how we do the rest of it. The way this is built is actually pretty cool. It's just a stack of aluminum plates with these long screws holding them together, sandwiched on the linear bearings. And any of these mounting pieces in there are just another piece of the sandwich that has these attached. It's actually pretty smart. Basically, what I think I want to do, I'm gonna snippy snip these guys, and then I'm gonna make a plate that goes to the front, and we're just gonna use the laser to weld it right here because the laser is good for that. The heat affected zone is not as big as if we were just welding, so I think we'll be able to get away with it without cooking the bearings. Now we can make our plate. You can see I cut a piece of the corner of that sheet off and put 2 mounting holes on there. That is for this strap, which will hold the laser in place. And this, we're just gonna weld it right here. So I technically have the wrong liner for aluminum wire, so I was only able to get it to feed for like 2 tacks. But then I tried it TIG style, and that worked fine. Anyway, shameful aluminum welds aside, we got a laser on a gantry. Very frickin' nice. We gotta stiffen this frame up a bit before we do anything worthwhile with it. So I'm gonna make a frame for it out of steel. Aluminum's too frickin' expensive, man. So, we got a little frame. Look at it, it's nice. The idea for this frame, we can take our little printer here and it fits right in there. So now we just line the top of this up with the top of these tubes and attach our printer to this frame. I'm literally just gonna use self-tappers. It's fine. So it appears I've got 15 minutes of footage of struggling to get this thing clamped and 0 minutes of footage of actually bolting it on. So, ta-da! In order to fit our little sidewalls in here, we're gonna have to cut the aluminum on this a little bit. That is all according to plan. These pieces should fit in here now. Just about. So I guess I'm gonna remove this and we can weld our plates in. If anything, this laser welder is making me a better welder in that I'm less experienced with it. So I'm cutting less corners and clamping everything up and doing all that, which I usually never do. Yeah, every time I'm about to start welding with this thing, I go like this. It's like muscle memory at this point. This little slot is where we can install a motor mount for a stepper motor. Ah, fuck. Okie doke. Let's start installing some hardware. Stepper motors go right here. Oh, is that out of focus? How embarrassing. Bloop, bloop. Beautiful. This is our print bed, and our print bed gets these nice linear bearings installed, 1 in each corner. Just like that. Now we can install our, oh, hold on. Gotta take these off. Oopsie. Now we find out if I did everything right. Gotta line all this stuff up. Hey, that's pretty smooth, man. I think we actually got it right. I do not know how to get the lead screws lined up properly, but one thing at a time. I think I can just drill the mounting holes out a little bit to get our little extra bit of play, because it's very close. It's not that far off. Yeah, we got space. I'm gonna do that. You can't make it perfect, make it adjustable. It seems to fit. I'm gonna struggle some tiny little screws in there, and then we can figure out how to get this all, you know, So I basically spent the whole morning getting this old CNC computer out of boxes and running again. But it works now, and I hooked it up to this thing just to see how everything works, the way I have it set up, and that's a pretty nice little platform we got there, man. We're basically at a place where I just have to do the wiring and figure out how this is all gonna work. I think I'm gonna run it all on Linux CNC just because I already have this computer set up to do that. The only thing between me working on getting all these axes working and right now is 4 self-tappers. Look at that, we got a CNC machine now. So, yeah, I'm gonna take this inside and do everything I can to get everything working. So for a CoreXY gantry, the motors don't directly map to the X and Y axes. Instead, if one motor is turning, the gantry moves diagonally. If both motors are moving in the same direction, it moves along the X-axis, and if they're moving opposite from each other, it moves along the Y-axis. There's a tool made by CoreXY on GitHub for actually understanding the relationship between the motors and the belts that I found super helpful. Links in the doobly-doo. We can calculate the kinematics with these 2 equations, and really, we don't have to do any of that because there's already a module made for this in Linux CNC. We're homing! The machine is working good. We can move all the axes. The Z-axis is working very well, and I haven't even put the upper things on. I think I might just not even put those on at all. Before moving forward, I want to go ahead and install this Sharpie on here, and we can use that to try and square up the gantry. Just make sure everything's okay. Honestly, man, for what I'm trying to do here, Sharpie accuracy is good enough for me. So, that's done. I guess we just have to attach our laser head to this and start trying to get this thing to do something. And you know, I don't know if there's anything that would really shift this around, but I think it might be smart to put a little strap across the top here. Boop. Now any flexing of this part is just the whole axis flexing. So yeah, maybe that's why CoreXY isn't the best idea for this. These 2 wires are gonna be what turn the printer on and off. So we gotta get in this switch to connect this. I think I might just solder it like boop boop. Yeah, let's do that. Boop. Boop. That shot was embarrassing because now you know just how ridiculously dirty I keep my soldering tip. Shameful. And the last thing I wanted to do was add like a stick or something to get all this stuff out of the way, but I was messing around with it. It almost looks like we can just clamp it over here. Boop. Yeah, I think that'll work just fine. Those are all the extremes of the table. We just gotta make sure to get all our shots from down here. Honestly, I think we're just about to a point where we can actually start running this machine. So I've gone right ahead and I have printed a bunch of build plates. Through cutting these things out, I kind of realized that I made the build plate unnecessarily large. I don't know if I'm really going to use all of the space that we have here, but maybe we can figure out a good use for it. These plates get anchored down with these machine screws all the way around. And when I say all the way around, I mean as far around as I can get with the amount that I have, which as of right now is unknown but optimistic. Hey, look at that, we had enough. I broke the hat out, guys. It's officially winter. Damn it. We've got our plate on there. We can start trying to print on it. The machine setup is just staying the same. We just have a very simple XYZ machine right now with no extra fluff, and then the on-off for the trigger on the laser is just a ka-chunk ka-chunk for now. And then all the fancy stuff like waiting for it to cool and whatever, we're just gonna do that in the G code. That's a lot easier for me to do. So we're gonna start with the machine like that, and if we find that we need to add more stuff to make it work, then we will. You know, start with the lazy thing. Oh, I added this little string to hold the line up, and check it out, I made an oopsie. I drilled a hole in the metal on the inside and kind of just went bang right into the frickin' plexiglass, so yeah, we got a leaky roof now, dummy. Anyway, let's start doing some test prints. We're gonna switch this thing over onto shop air, because doing this with argon would be crazy. You heard that right. We can use just compressed air as a shielding gas on this laser. The manual says that you shouldn't use this if you need a very good weld, but worth a shot, because running out of argon is kind of my thing. Now then, there is going to be no point in this when I have the laser turned on and I don't have goggles on. Yeah, man, I think there's nothing left to do besides to do it. I think I'm kind of trying to stall because I'm scared. Well, whatever. Don't be scared, just put on goggles, right? Plus I get to look cool. Very RoboCop aesthetic. Here we go. Yeah! Okay, problem. Couple problems, actually. One, the wire wasn't properly feeding. Two, when I hit stop, the laser kept going, which is also a bit concerning. Okay, here we go again. Man, wire does not want to feed into the correct spot. It could be a height issue, actually. Okay, also, it seems that we're not actually getting continuity from the ground clamp. You can see, works fine when I touch it to the head, but, oh, well now it's working. I think we should probably handle that just because consistency is a little bit important when we're trying to troubleshoot things. The ground clamp on this machine isn't a traditional ground clamp in that there's no actual welding current running through it. It's just checking for continuity between the head and the machine. So we can just hijack one of the wires already going to the head, tie one end to the head and one end to the frame. Beautiful. Here we go. The weld is a bit messy, so we probably are gonna have to adjust our layer height. Hey, I don't see any reason to not just let it do another frickin' layer, huh? Okay, I'm calling it. Since we have no real way of dealing with the heat, I don't want to like catastrophically warp our frickin' Z-axis. We might have already done that, honestly, but you know, positivity. You can see a lot of cracking. I mean, it's obviously not slag, there's no flux, but yeah, what's up with that? Oh! Oh! Oh, God! I guess that's what they mean when they say that it's significantly weaker doing this with shop air. For a first barnacle, I'm happy. Now, we have to deal with the heat before this build plate gets warped. Ideally, we can just CoreXY printer this thing and have forced air going across the bed right at the height of the torch. So it's always hitting directly at the weld. There is a possibility that it'll take just way too long for us to get down to a decent temperature like that, but I don't know. We won't know till we measure. Let's give it a shot. Obviously, we're not just gonna be able to use normal 3D printer fans. We want something a bit more substantial. This is a blower upper thing for like a bouncy castle. I don't know. They end up at Goodwill all the time and I always get them because they're very strong. This is what I use for the ventilation on the CO2 laser. I have this precariously propped up on some stuff to get it up to the correct height, and I'm going to point it vaguely in the direction of where our print head is. I think I just want to print a layer, measure the temperature, turn this on, and see how long it takes to get back down to more acceptable temperature. And we'll do that for a couple layers just to, you know, see how it changes. As you may be able to tell from this time lapse, I had trouble actually printing layers again. I found that the height of the print head was absolutely crucial to be in the correct position. Too high, and it would drop little droplets of metal onto the part and get stuck. Too low, it would miss the puddle entirely and get stuck. Well, shit, we haven't had that problem in a while. I eventually figured this out, and we got our data. So, I would run one layer, turn on the cooling fan, and every 30 seconds measure the temperature of the part. And as you can see, we're actually heading towards a point of convergence. Now, that point of convergence is beyond the data that we collected, but I'm not willing to wait more than 3 minutes per layer. That's crazy. This was the best barnacle that we printed. This is 9 layers, and it looked beautiful until I started messing with it. It didn't look as cracked as the first one, so I thought that maybe it wouldn't flake away, but as you can see, it's got no structural integrity whatsoever. So I honestly don't think that we're gonna be able to get away with just using air as shielding gas. I assume that's what the problem is, but whatever, one problem at a time. The other issue, there is a height difference between the layer start and the layer end. You can really see this difference in this shot that is conveniently focused on the wrong spot. This is caused by a few things. The machine is set to pause at the start of the layer to form a puddle, and at the end of the layer to allow the wire to recede from the puddle. This can definitely cause a little bit of a bumpy, but the real problem is when that bumpy compounds over a bunch of layers. We can mitigate this problem by randomizing where each layer starts. Another possible contributor to our bumpy, because of the bead thickness in the slicer, the machine starts and stops a bit further away from each other than I'd like.
That's quite big.
To fix that, we just need to take the first movement in the layer and add it to the end of the layer for a little bit of overlap. Well, I guess our build plate got a bit welded to the Z-axis, and I already kind of bent it trying to pry it off. Not to mention I broke my screwdriver. I'm still gonna try and salvage it, but we may have to build a whole nother Z-axis because this bend might make it wonky on the lead screws. That sucks. Ta-da! As you can see, our build plate is suddenly not bent, and 3/16 and not properly leveled. Yay! I went ahead and rebuilt the build plate out of 3/16 material. I thought that we'd have less warpage issues with that. Also, it's the only material I had. I don't know why I was completely incapable of getting this build plate leveled like the other one. The other one, I could just measure one side, move the gantry to the other side, and then unplug a motor and match them up to get the thing in the correct position. This one didn't like that. So instead, I've leveled our plate with precision stacks of washers. And honestly, I think it's more level than the last one was like this. As you can see, I did a little barnacle test print, and man, we're getting pretty thin on these guys. It's actually looking pretty nice. This is the 3rd layer of a print. The first couple layers always end up a little bit janky, but by the 3rd layer, man, it's thin, it's pretty smooth, it's pretty awesome. But it still has its flaws, and the only way to tune those out is a one-stop ticket to Barnacle Town. I've certainly been up to barnacling, as maybe you can see on some of these. We're getting better at closing that gap. Now, the new problem that has arisen from that is the wire constantly gets stuck. And I can tweak the settings, like I can tweak the wire feed and I can add a delay, and it helps, and we can get it down to happening, 20% of the time. But if it even happens 1% of the time, it's gonna happen. We need it to not happen. And I think the only way that we can ensure that it never happens is if we have separate control over the wire feed. So, I started digging around in the machine. Uh-oh. So here's the nicely organized guts of the machine. It's actually pretty straightforward, and they have pretty good documentation for it, which is awesome. But basically, these 2 terminals, this guy and this guy, are given 12 volts when the wire feed isn't running and 0 volts when it is running. We can probably use that, but that feels a little bit more invasive than I want to be. I don't want to supply my own 12 volts that is like out of sync with everything else, and I don't want to tie on to the common ground of the machine either. That feels too risky for a guy who doesn't know anything about anything to do. I would much rather just have a ka-chunk switch that can cut power to the wire feed motor or something like that. So, in order to be less invasive, we're gonna take the wire feed apart. That makes sense, right? Well, here I go, being non-invasive again. Oh wow, look at that chunky wire feed motor. That's cool. We're gonna do the old snippy relay option, which that's what I wanted to do anyways. So we're good. Man, it's gotta be said, this CNC PC that I made, absolutely worth all the pain and suffering. Honestly, it's freaking amazing to just be able to make a quick plug and add features to a CNC machine. This should be a product. Now, yeah, a very niche product. I don't know if there's that many people who need to have a easily swappable CNC controller, but I'd buy it. Well, I guess I wouldn't, I already have one. Anyway, I've gone in and I've edited the ini and how file to add our second parallel port, which gives us tons more outputs. Now our coolant flood controls this relay. And I just put this on a separate relay on a really long line so we can stick it inside of our wire feed. I also went right ahead and wired up coolant mist to the first relay on this board, and I'm using this board because I also have digital out 0 through 3 or 4 set as M64 codes, so we can control more relays if we want. But for now, that relay is just going to be used to control our, actually our coolant, the air blower thingy. So, we got our relay. Let's throw this into the wire feed. Now then, we can do a little bit of a snippety doodah in there. And just like that, we've got a fairly non-invasive wire feed control. This is going to solve our problem because now we can start the laser and wait for a puddle to form, then start feeding wire and continue the layer. And at the end of the layer, we can stop the wire feed but keep the laser running to allow the wire to melt back a bit before turning everything off. And our other relay will just turn the fan on in between each layer for a set amount of time. Here goes nothing. Yeah, that's kind of slow. Let's kick it up a notch.
Engage.
That worked incredibly well, man. I can't believe it. We made it to layer 38. And yes, we have our flaky flakies, but underneath is a pretty decent surface. And honestly, I mean, it's not as clean as the flakies look before they start flaking, but it's still pretty clean for, you know, what we're frickin' doing here. That is really cool. The one problem, I don't love this flaky slag stuff, so whoops. I think we're gonna have to try and do our print with a shielding gas, and ideally, I don't want to use argon because it's very expensive. But I read in the documentation for this machine that you can use nitrogen as a shielding gas, and I got just the thing that I've left sitting in the rain for 4 years. Here we have a nitrogen membrane. Now, I've left this in the rain for many years, so who knows if it's working, but I sure do love the idea of free shielding gas. Now, I don't know how much this is actually going to pertain to the video, so I think I'm just going to post this part on Patreon. So, yeah, do the thing. Links in the doobly-doo. Thank you. The guts of the machine actually looked beautiful for something that I left in the rain for many years. So you're not missing much if you don't go to Patreon. It didn't take much to get it all working. I've got a little oxygen monitor here. Let's check this. Definitely going down. And we got an alarm. All right, I'm turning the ventilation on. Ay, ay, ay. Yeah, that got low. I think it's safe to say that it totally works. Like, we're definitely getting less oxygen in the output here, and significantly less, because this has taken a while to recover and it went down quick. Now, my one concern with using nitrogen as a shielding gas is the fact that nitrogen is the you don't know that you're suffocating to death gas. But anytime the printer's running, I'm gonna be running the ventilation. I'm gonna have... Shut up! Sorry. I'm gonna have the oxygen monitor running right next to the machine in a place where we'll get a good reading. I don't know. I think we'll be safe. I guess if this takes me out, sorry, Skyfire, for not fulfilling our agreement. I definitely need this meter because I, like, instantly feel lightheaded even though it's fine. Sometimes paranoia is a good defense mechanism, but most times it's just annoying. Anyway, let's go put this in its home. While we wait for that to warm up, we can add the one final thing that is absolutely necessary. Webcam. I've made some absolutely disgraceful 3D printing time lapses in my time, so this will fix that. The webcam will just be hooked up to a laptop. This way we can take our time-lapse photos, but also I can remote access the laptop to monitor the printer while it's going. Between each layer, we can use an M64 command to trigger a relay, which will tell an Arduino Leonardo to emulate a spacebar keystroke on the laptop. Taking a screenshot. Now then, let's do a nitrogen print. So we're graduating from barnacle to nipple. I like a sphere because it gives us a variation of different amounts of overhang for it to do. There will come a point on this where it fails, but I don't know. Let's see where that point is. That is incredible, man. Now, full disclosure, the wire got stuck once. Luckily, I was right there and I just snipped it. So, I think we need to increase our dwell time or something. Hopefully, it was a fluke. But, you know, I will increase the dwell time to prevent the wire sticking. But man, we got a very decent overhang towards the end here. You can see it got a lot messier towards the end. We're like bubbly and it didn't fully close the top, but I honestly expected it to stop working like around here. I can't believe it worked at all. So we can do some pretty decent overhangs, and with how these overhangs are working, can we print a full ball? That would be insane. We've got ourselves a little bit of a projectile here, huh? It certainly is not perfect. The back looks very consistent. The front, we've got this little stippling, and like here is where that wire was, so it's not perfect. But, I mean, it's pretty good. The one problem, we are clearly having a bit of a egging going on. So if you remember, our little wire was pretty much on the front and our little nipple here was kind of facing this way. So that puts our warpage diagonal, which points to it being some kind of problem with one of the motors, since, you know, one motor moves and the gantry moves diagonally. And I came to take a little look-see. Check this out. There is a bit of slop in the direction that the warpage happened. And investigating a bit further, this is able to move a tiny bit. So, we might just have a loose set screw. Look at that. I love a problem that can be fixed by tightening one screw. Now, despite our couple issues with that last print, I feel fairly confident in this machine now. Let's print something for real. These machines are kind of absolutely perfect for vases, but that's what we did last time. That's boring. So here's what I was thinking. I found this pretty cool chess set on Thingiverse, designed by Big Bad Bison. Well, it's designed to not need any support and still have some pretty interesting stuff going on. So I think it's a perfect contender for what we're doing here, and this would make a sick chess set. Now, I guess the most iconic piece would be to print a king first, but I'm a man of the working class. We're printing a pawn. Okay, the preview looks correct. These little tiny spindly things may prove to be problematic, but only one way to find out, man. Let's send it. Oh my God, we went and did it, man. We went and did it. Clearly we got some problems here, but we did make it all the way through a print, which is awesome. The flaking seems to have returned. Oh, that's a dirty brush. I'm not quite sure why the flaking came back. But, I mean, it doesn't look terrible. Let's get this thing cut out and take a closer look. Queen me. I think that's checkers. it really didn't turn out all that bad. Now, there's obviously some imperfections. We've got porosity at the base. This slag is hard to chip out up at the top here, but our spindlies at the bottom kind of actually spindled. But yeah, we got random bits of porosity dotted around here. This overhang was a bit too steep and a nightmare. The back of his little head got a bit of a tumor. There's our big boy vase. The welds on this are so much more flown together. They kind of went together much better than on this guy. You can see the layer lines so much more clearly on this one. But also, this is so much tinier. If we blew this up to this size, I bet you it would be comparable quality. I had to make a little table with the cooler because all my surfaces are covered in 3D printer right now. In the interest of saving money, I'm gonna print a larger pond, still with nitrogen. If it looks like we're getting screwed by the same problem again, if I even see some visible porosity on it, I think I'll call it, and we're gonna try again with argon. I will say, while maybe the quality isn't quite dialed in yet on the laser was so much more hands-off than this frickin' thing. I was babysitting this thing all damn day. And this, I was babysitting it, but I was also getting chores done. So, let's print a big boy pond. Blam! Well, we got a big boy. It's okay. I sandblasted it to try and get a lot of the slag off. Not as much slag came off of this one as the little guy. We still got quite a bit of porosity. You know, it's cool that it worked at all. But I don't know if we've actually improved from the last metal 3D printer in any substantial way. Although, these spirally little ponds with little tiny, you know, spindly bits, this is kind of running on hard mode. I don't even know if the TIG printer would be able to handle this print. I think the little spindles would kind of get screwed. The amount of heat that we get from the laser printer is far less. When I was running the TIG metal printer, that thing was ridiculously hot the whole time, even with the water cooling. This, I actually turned the cooling down to 30 seconds and no problem. I think overall this is a better printer than the last one I did. And to prove it, let's print a vase again. I actually solved the wire getting stuck problem rather than at the end of each layer having it delay without the wire feed going to melt the wire back. I have it start to lift off. I've added a Z hop and I don't turn the laser off until it's up at that height. So the wire stops going and it melts back as it's getting pulled out, because the problem with it getting stuck is it would melt back under that delay, but then we would do a rapid movement right back into the hot part and it would get stuck. So the Z-hop seems to have fixed that problem. So we're gonna do a full print with that. And I'm gonna try using argon as a shielding gas. I don't know if the nitrogen generator is generating pure enough nitrogen to actually like be a good shielding gas. Also, if nitrogen was a good shielding gas, it would be commonly used. There's a lot of it. So, what's one more day babysitting a printer, right? Would you take a look at that beautiful vase? It's definitely got its issues, but it worked pretty good. And check this out. Here's how much argon we have left. This is the first time in Cranktown history that I did not run out of welding gas. Overall, it looks pretty frickin' nice. You can see this little layer shift. That is 100% my fault. I noticed that the line was getting pulled in a funny direction and I tried to mess with it, but I ended up just kind of screwing everything up. But whatever, it's just one layer. The rest of it turned out more or less okay. This side, that's all rough with all the diddly sticking off of it, is a problem that did not show up beforehand. So I don't know what's up with that, but because of the loop in the wire feed liner, it puts a bit of a bend in the wire and it comes out of the machine at an angle. And this side was on the side that that wire was pointing towards. So it was kind of getting stuck on the edge of the puddle and causing little diddlies. But that is very easily fixable. We just got to figure out a better way of routing the liner. Other issues, we had a bit of problems towards the top. This was my fault. I accidentally hit pause and didn't notice until I added a big bubble. But otherwise, man, I think it looks pretty sweet. Compared to the TIG vase, I think it is an improvement. We have a bit higher definition on this guy, despite it being a little bit smaller. And man, it is significantly lighter. And that is just a function of the smaller layer lines. So we'll be able to do much more refined parts with the laser printer, which, you know, I totally expected that. I think that we do have a marked improvement over the last one. If not in quality, which I would argue it's higher quality. Some of these problems will be pretty trivial to tune out. But definitely in reliability. This machine was rock solid. It got to the point where I wasn't even really worried about it running. The only time that I would intervene is when I would come back into the shop and get myself paranoid. Yeah, that's a personal problem. That's not really a printer problem. And I do think I want to take this further. I know I say that at the end of every 3D metal printer video, and I mean, I've been taking it further. But I think I want to take this specific printer with the laser further. And it's got to be said, man, the Skyfire laser welder is incredible. I had that thing running all day for multiple days printing these parts, and it didn't even hiccup at all. No problem, everything works just fine. It's a really cool tool for more than just dumb stuff like this, but it's also cool for dumb stuff like this. Now, I'm under no delusion that this printer is going to be able to be making precision parts, but, I mean, I gotta get the thing working reliably, if anything, just so I can have this chess set, right? I'm doing another video on this someday, but for now, I need a break, man. Yeah, I'm over it. Either way, super stoked on this, excited to take it further, and, yeah, hope you liked it. If you like what you saw, leave a good old dinger. If you're interested in Skyfire or any of their laser products, including this one, links will be in the doobly-doo. Also, if you could, support me on Patreon. I will very much appreciate it, and there's gonna be a couple videos just from this one that I'm just gonna post on there. Otherwise, thanks for watching.